Well, okay, it's 10 o'clock in the morning. This is Saturday, April 25th, 2020. We timestamp and date stamp stuff out here in the desert because it gives you a little bit of feeling of what's going on. In particular, right now, it is 83 degrees. By the end of this talk, it will be 87 or 88 degrees, and by 5 o'clock tonight, it'll be 105 degrees. Every hour here, every 20 minutes, every 10 minutes, a degree goes up or a degree goes down. So you kind of get used to the fact that the temperature here swings dramatically. All right, let's talk about the foundations of a tiny house. What we're going to do is we'll spend about 10 or 15 minutes talking about the foundations and the structure of a tiny house. And then I'll take questions from you. I've got these little blue jobbers on the side here, so you guys can ask some questions. And hello from New Hampshire. We're at probably not 100 degrees today. And we'll take your questions and we'll sort of zero in on some stuff. I was thinking about this last night. Let's assume for this discussion that there are no laws. There are no laws. Nobody's going to tell you what to do. You bought yourself 50 acres of land out in the middle of wherever it is. Nobody's there. Nobody's going to tell you what to do. You can do anything you want, just like the 18th century America. Anything you want. Even the Native Americans aren't going to tell you what to do because they don't know and don't care. Okay. So if you can do anything, the problem is you still have rules. And the rules that you have to abide by are physics. If you think about it, a 10-foot long piece of wood is going to have 10 times the pressure at the top than it's going to have at the bottom. If you build a wall, I don't care what you build it out of. You can build it out of lead. You can build it out of carbon fiber. You can build it out of anything. But the fact is that if you build a 30-foot long by 10-foot tall wall, you're going to have 30 times 10 or 300 square feet of surface, like a sail shape. And as the wind blows against it, the problem you're going to have, again, this is physics. This is not people who are telling you that you can and cannot do a thing. But the fact is, at the bottom of this thing, you're going to have relatively zero pressure. It's no big deal. But if the wind's blowing at 2 miles an hour, by the time you get to the top, 10 feet away, 30 feet of sail shape, you could have hundreds of pounds of pressure. So if you don't build the thing to take the pressure, it's going to fall down. Or it's going to crumble. Or it's going to peel apart. Or the rain is going to find its way underneath and seep in. Or the tiles on the roof are going to fall off. Or this or that, and pretty soon, a year, 2 years, 1 year, 6 months, one storm. Out here in Arizona, all right, so today in Scottsdale, it is 85 degrees. There isn't a leaf moving, nothing. There isn't a cloud in the sky for probably 500 miles, and if you built a teepee, it would just sit there, which is fine. But I know, because I've been here, that by July or August, when the monsoon storms come, you can pretty much assume you're going to see storms that are severe enough to build a Grand Canyon. And if you don't take that into account, you're going to be gone. And if you build your structure in the bottom of one of these things and it storms 50 miles away, the water will come in and you will be washed away, never to be seen again. So when you design your tiny house, when you design any house, but when you design your tiny house, you have to think about the laws of nature, the laws of physics. What am I going to be dealing with, and how can I build this thing to stand up to what I am likely to see? The next step that you might want to have is when you say, what am I likely to see? Then you add a level, which is, what might I see? And then ultimately, what can I imagine I might see, but there's no chance I'm really ever going to see that? For example, you say to yourself, all right, I live in Miami. It is possible that, is it worth getting an engineer to review your plan? Yes. The answer is yes, it is. If you aren't good with numbers, you need to find somebody who is good with numbers. And Lori mentions the storms scare me. Well, storms are a problem because storms blow houses over. Storms blow big houses over. So if you've got a small house that isn't made for the storm, you've got a problem. So let's say you live in Miami and you say to yourself, all right, I expect that once every 10 years, I'm going to have 150 mile an hour wind. The problem with that wind, by the way, is not that you're going to have 150 mile an hour wind, which is a problem itself, but you're going to have 150 mile an hour wind for upwards of 10 hours, 12 hours. That amount of pressure, you can build a structure that can tolerate it. It does happen. There are people who have done it. But you're going to have a hard time building that structure on wheels. And that's a problem. So let's start from the very beginning. The bottom part of our house, our tiny house, our thin house, our tiny house, whatever we're building, the bottom, the bottom, the foundation, if you were, is steel. It is a steel platform, 8.5, 10 feet wide, 24 feet, 30 feet long. And underneath this steel platform, we have put 4 wheels, 6 wheels. Okay, that's fine. Without any question, hi Lindsay, without any question at all, you have to put jacks on the corners. If you do not, you're now putting all of the force, the downward force of your house onto 4 rubber wheels and 1 pin king jack. And while that could work, it's a lot of pressure for a lot of time on a minimal amount of rubber. And if you weigh 200 pounds like I do, 220 pounds. If you weigh 200 pounds like I do and you walk around the thing, it's going to wobble, which is going to become irritating after a very short time. So you need to make sure that you put 4 5,000-pound or 4 7,000-pound jacks on each corner. And then when the house gets to wherever it's going, you put a foundation on the ground. It can be an 18-inch cube piece of concrete, or it can be tiles, or it can be it can be anything, but it's got to be firm. If you study Chicago architecture, the old days, we're talking about the 1800s, in order to build the very first skyscraper, they had a problem in Chicago because if you look at the way Chicago is built, it's built next to the lake and it's built on a muddy platform that is Lake Michigan's shoreline. So you don't get down to rock until about 300 feet, which is not as hard to do now because you've got power machines. But back in the 1800s, it was kind of a thing to do. So they had to design or figure out how to put up the buildings. And the answer that they did was they dug down, they built a platform of concrete, then they put the building on then they put the pinions on the concrete, the stanchions on the concrete, they filled it all back in with dirt, and then they built the building on the pins. That's how you do it. That's not so different from what we're doing with our tiny houses. We basically take a steel platform, the trailer, we put 4 jacks on the corners, we level it all out, and then you build your structure going up. But you better make sure that your structure can take the forces that you're likely to see. You better make sure your structure takes the forces you could see. You better make sure your structure takes the forces you might once in a lifetime see, because you might see them. If you don't do these things, it doesn't matter what inspectors say, your house will blow down or fall down or rain over or whatever. This is a problem. And you want to build something that will last years and years and years and be of no concern. You have enough concern with your daily lives that you don't have to worry about whether your house can fall down. The other problem is that one of the things that you have to deal with is strength to weight. You can build the strongest house in the world if you build it out of concrete blocks. The problem is a concrete block will be too heavy to carry down the road. So that won't work. You can build it to be 40 feet tall, but it will be too weak to tolerate the wind forces. So that won't work. So when you talk about this thing about engineering, basically what an engineer is going to do for you, unless you want to do it yourself, but if you can't or don't know how, what an engineer will do for you, a SIP envelope is a delightful idea, but a SIP envelope has 2 real problems. The first is it's heavy. So you're going to be surprised at what you can't have on the inside of your house because you used up all of the weight on the outside of the house. The other is the SIP envelope requires a truly huge amount of forethought. Because the walls are all pre-plumbed and pre-wired and prepared, you have to know exactly what it is, and to change it is really kind of a thing to do. Don't want to do it if you can avoid it. However, having said that, if you are pretty confident, or if you buy a tiny house from a manufacturer like ThinHaus who uses the SIP model, it's a great idea. It's a great idea. Insulation is pretty good. There is one thing about SIPs that we're not crazy about, but people are. I'm not 100% comfortable just yet with the off-gassing of the foam product. I could probably get there, but I'm not quite there. So you want to make sure that that product is healthy enough for where you want to go and what you want to do. In our world, we've decided the way to do it is steel. If you go to our website, thinhaus.com, you'll see what we're up to. But we've basically framed the thing out in steel, and that gives us all the flexibility that you're talking about. ThinHaus, ThinHaus.com. ThinHaus. So anyway, so that's the overview. The idea is, I'm not saying to you that you have to worry about inspectors or design. You don't have to worry about anything other than nature and physics. If you design your ThinHaus, or buy from someone who did, that is understanding of what nature and physics will do, those things will match the residential codes. That's why they designed the codes. The codes are designed for two things. One is safety, the other is fire. They don't want the thing to burn down. Okay, so let me do one more thing before I open up. All right, I want to offer to anybody who wants it. We made a little book. Here's our little book. Our little book is called The Big Book of Tiny Houses. It's a little book. And it's free. It's 16 pages, I think it is. It's free, but it's only in paper. Here it is. It's a piece of paper. It's paper. It fits in an envelope. If you would like one, we would be happy to send it to you at no charge. All you got to do is send a email to littlebook@thinhaus.com. Tell us your address. Tell us where to send it. We'll take an envelope. We'll put the address on the envelope. We'll drop the book in. And off you go. It's a little bit. It talks about, it's 101 answers about all things tiny. Then it talks about places to cut a few corners and what are the pitfalls of doing it yourself, and do I need a certificate of occupancy? And then also, there are 101 questions of things that we've come across as we've done our shows. And anybody is allowed to do it. I see right here, little book there you go, littlebook@thinhaus.com, magnesium oxide coating. What about magnesium oxide coating? What are the most common codes to be aware of? All right, the answer to this question is the International Residential Code, IRC. That is the code that almost everybody in the United States uses to build a house. We're contractors in Arizona. That's how we build a house. You own a house in Lincoln, Nebraska, no doubt, if you go to the building department, they'll tell you that they use the International Residential Code. It's the code that says walls have to be this way, floors have to be this way, things have to be this way. If you build a house to that code, you are going to build a house that is probably as safe as possible. It's a good thing. There is now the Appendix Q, which is the tiny house add-on to the IRC, and they're getting to points because there's a thing that says that in the International Residential Code, a room has to be 6'3" in height or minimum, but that doesn't work in a tiny house. So Appendix Q has made some changes. That will grow as time goes on. So the answer is, what code do you want? You want International Residential Code. We build to NOAA certification. There is the RVIA certification, perfectly nice folks. A little more mobile platform than we've chosen, but perfectly fine. Pacific West has a certification that is great, and if you find that, that's a good thing. But they won't do an individual house, so you have to find a manufacturer that does it. But if you're going to do your own house and you'd like to have someone take a look at it, along the way, giving the NOAA folks a couple of grand is probably a perfectly great idea. All right, this gives me lots of considering. Great talk. Thanks, Dorothy. What else we got? How about zip panels for outside the envelope? Zip panels for outside the envelope. Well, the problem with outside the envelope. All right, so let's talk about the envelope. All right, so you built this structure. It is what it is. The problem with the thing is, the problem with the thing is that the more weight you add, let me come back. So you have this structure with your studs and your whatever you got, and your roof and your floorboard. The sheathing is probably going to add stiffness. That's a good thing. You need stiffness. You want stiffness. But if you start to add too much weight, now you're blasting past the space where you can have any room left for an interior wall. You can't have A wall. You can't have drywall because that's way too heavy. You can't have lap walls because that gets too heavy. So you have to be careful. You have to balance between sheathing stiffness and weight. What would be the perfect sheathing stiffness? The perfect would be 020 titanium sheets. Now I just spent $450,000 to build a tiny house, and it's a killer. But you're not going to do that. So you can get clever, and you can use straps. You can use, we use 1/8-inch poplar because that is a lovely prefab board that is stiff and insulatable and light enough, but it only works because our frame is steel and the whole thing is stiff without stiffeners. So you have to balance that. But by the way, anybody who wants it, again, if you just send me jay@thinhaus.com, anybody who wants copies of our plans, they are available at no charge. Happy to send them. I think what you're going to find is while they're pretty neato, you can't build them. I'd be happy to let you try. I mean, it's no big deal. But there are techniques that we are using that are just not easy to do. Steel framing is a skill, and it will take you 6 or 7 tries to get it right. And after that, you'll say, well, hell, I'm not going to even bother because I've already, I'm living in tiny house number 1. So you can take a look at what we're doing. I'll give you some ideas. The California corners, the Norris corners, and some of the things we're doing. Our lofting designs are the nuts because we have deflection points at less than 1/8 of an inch over 10 feet. You could literally have a dance party up in one of our lofts and the thing won't even move. And it's because of steel. So anyway, what is the address? The address is, there it is. All right, Lindsay's got it for you. ThinHaus.com. Susan, go in and out to whatever that. Okay, I'm playing. Hi, Randy. Okay, so anybody else have any questions or anything else we want to, any other tangents you want to go after? I'll be happy to have a little fun with it. Let me talk a little bit while I'm waiting for you guys to think of what I want a tiny. I just sent an email from my Nook. It's funny. Oh, what gauge steel? Very good point. Really good point. This is not an easy question. I will give you the answer, but it's not an easy question. Home Depot sells 20 gauge steel. Too flimsy. It is interior grade studs. It's not built for the exterior of a house, not built for wind load. Doesn't work. It's too flexible. It doesn't work. You can go to 18 gauge and get a little more stiffness, but it still won't work for exterior gauge. You can't buy anything stiffer at the home stores. We've tried. Can't. We are at 16 gauge. 16 gauge is 053. It is insanely strong stuff. It is the thinnest we can go for a 12-foot length and still handle 150 mile-an-hour winds. Let me go back again. There's somebody talking in the background, not in my place. 16 gauge, 12 foot long, 3.5 inch by 1 5/8 to represent a 2x4. Clark Dietrich. They make this stuff. We order it specially and they send it to us. And if we need a piece that we don't have, we're out of luck. It takes a week for us to get it. So this is not a product that's going to be easy for a do-it-yourselfer to do unless you partner with a manufacturer like us who has it. We can send it over to you, whatever. It weighs approximately a little less than 1.5 pounds per running foot. You cannot cut it without a very specialized steel saw. This is not something you can cut with a handsaw. This is not something you can cut safely with anything less than a $1,000 piece of equipment with a $350 blade. So this is not a do-it-yourselfer's kind of piece of equipment. Again, you could, Volstruck, for example, makes kits. And what they do is they fabricate these things and cut them to size and then send them to you and you bolt it all together, which is incredibly cool. They do some things that we don't do. And let me change it. We do some things they don't do. For example, we go to 16 gauge. They pretty much stay at 18 gauge. And the counterpoint to that is they use a lot of cross-membering and crisscrossing, which we don't do. It's very cool. Weight-wise, it's essentially the same. But we don't do it. So we have there. You'll find on a ThinHaus, you'll find less parts. Again, go to ThinHaus.com and you'll see the framing. You'll see how it goes. You'll see that we don't have. We have approximately the same amount of metal, but we don't have as much visual metal. We have thicker pieces of the things we do have. What is the rigidity of a prefab cargo trailer for pre-built? What is the rigidity of prefab cargo trailers? Yeah, they're not going to be stiff enough. I mean, you can do the numbers on the thing. Take a look. You can Google it. You can say how much pressure is a 24-foot by 8-foot wall in 30-mile-an-hour winds. You're going to see that that's 300 pounds of pressure, and you're done. So you don't have to be the engineer to do the calculation. Google will do it for you, but you're going to, if you ask the right question, Google will tell you got a problem. Insulation. Okay, insulation is the thing, isn't it? Let me tell you what we don't use. We do not use spray foam. We are concerned about off-gassing. We don't use spray foam. We use rock wool, spun wool, and laminate wooden sandwiches with the steel frames in order to create 4-inch thick R19 and up spaces. They're crazy strong and they are wonderfully insulated. Remember also that we live in 115 degrees here, so it better be insulated. I'm not too worried about Steamboat Springs, although that's a thing I probably should think about. But if you're worried about the Tucson desert, you better have insulation, because otherwise you're going to be blowing a lot of air conditioning out into the desert during the summer. I mean, we're not going to have rain again until August. So there you go. All right, we've got another minute to go. So any other questions? We'll pack them in and see if I can. Let's see. I'm concerned about what you would do. Oh, the wiring. The wiring's a piece of cake. Just make sure you use grommets in between the steel. The steel comes with holes. So the wiring goes through the holes, through the grommets, and everything's fine. It's great. It works fabulously well. Thermal bridging. Yeah, thermal bridging's a thing. Not disagreeing with you. Thermal bridging's a thing. When you have steel, thermal bridging happens. So what you got to try and avoid is, for example, we use foam at the bottom, just like a house, to try and stop that. We use sandwich wood frame to avoid it on the interior and the exterior, but it can happen. And what we do is we overcompensate with the HVAC system to make up for it. But the entrance thermal bridging is a thing. All right. Anybody who wants me, jay@thinhaus.com. I'll be happy to answer any questions you got. What we've got, we're happy to offer, and we'd love to help you. And if you want to do it yourself, that's fine. If you want us to help you along the way, happy to help. Have a great day, people. Thank you.